Hey YouTube, this is Rob Godshaw. I'm going to talk today about how to make a weird like Mancala monkey face thing on a CNC router for the purposes of learning how to use Fusion360's CAM environment to make tool paths. And this part has been designed specifically to just show you all the different ways that CNC routers can move. So the first thing we're going to do is we're going to go from the design environment into this manufacture environment. In the event that you're using an older tutorial that was uploaded by somebody else in the past few years, this environment is going to be called the CAM environment. But that's only relevant if you're watching older videos. And you see that what we have here is we have a setup. That's from earlier. I'm going to actually delete my setup just so that my screen is just like yours. And you see all these different options in the ribbon. And these are different types of tactics, of strategies that the CNC machine can use to remove material to carve down material. In this case, our material is going to be plywood, and we're going to be carving this out. But if I go in and say, let's say I want to do a 2D operation, the 2D contour operation is one of the simplest and most commonly used operations. If I click that, it's automatically going to make me a setup because you need a setup in order to use the tools. But it's better to be explicit. So I'm going to hit cancel. I'm going to make a new setup. And what a setup is it's a set of operations you're doing on the machine. Specifically, it's on a particular piece of material in a particular orientation. So if you were going to do a flip, you would have a setup for the front and a setup for the back. But for 99% of anything you do in a CNC router, you're going to have exactly one setup, even if you're using multiple tools. The first thing we're going to do is we're going to pick the origin. This is the origin not from our modeling space, but what's called our work coordinate system, or our work coordinate space. And this is the 0 point, the reference point the CNC router uses to refer to. And I'm going to use the lower left corner on the bottom of the stock. So it gives us all these points, 27 points in our box that are reasonable options to put our 0. And we're always in this class we're always going to 0 off the bottom because it's a good way to good practice on CNC routers to 0 off the bottom because it will save the machine from unnecessary wear and tear. We've picked the 0 now. This is a great place for the 0 to be, but you might notice that our X, Y, and Z are a little weird. For the shopBot and every CNC machine I've ever used, the Z axis is up. So if we tried to run the part this way, we would end up with the shopBot trying to mill it from this point of view, and that's not going to work. We want the shopBot to be pointing down like into the eyeballs of this creepy monkey face. So now that we can pick the orientation, not model orientation, which is the default, where it just copies the orientation you happen to model in. But no, we're going to pick the orientation using any of these tools. For the sake of simplicity, let's just select the Z-axis and the X-axis. So the first thing it's asking for, that is highlighted, is what the Z-axis is. And since the Z-axis is coming out of the part, we just need to click something that's kind of that direction. And you see in the example, they want the bit to be coming parallel to that line, so they click that line. So we just need to click any vertical line or any horizontal surface. It can do either. You can see in the preview that you can either do a surface or you can do a line or a surface perpendicular to that line. So I'm just going to click this line. And that's kind of better. You know, Z is pointing the wrong direction, so we can go ahead and click flip Z. And I want my X and Y to be both positive along the part. So like I want the X to be flipped also. So I'm going to click flip X. That's confusing.
And you forgot to select an edge for the X.
Oh, I did. Thank you. I forgot to select an edge for the X. So our goal, there we go, that's our goal. We want, this is exactly our goal. We want Z pointing up, X and Y pointing toward our part, and we want to be on the bottom of the part on the lower left-hand corner of the face. And model is probably already selected, but I'm just going to be explicit. I'm going to click the X, so it's selecting nothing, and then I'm going to click the body. Then for stock, you can just say no additional stock for simplicity. The reason why we don't really care about stock is because it's only really useful if you have multiple parts, because this isn't actually, this just represents where the machine is where we begin. And we could run this as many times as we want on the shopBot, and I just think it's easier not to fill this out. But you could also do add stock to the sides and top and bottom, but you want to add nothing to the top usually, and just like a little bit to the sides. But for today, let's just do relative size box, no additional stock. You know, I changed my mind because the simulation will look better. Relative size box, add an inch to the sides, that's about 25 millimeters if you're working in metric, and nothing to the top, nothing to the bottom, and no rounding. Cool, so now you see we have a new 0 point here. It's not related to the 0 point of the model, which is over here. Now that we have a setup that we like, we can begin our tool pathing operations. And just to give a quick summary, our goal here is in the 2-dimensional, or really the 2.5-dimensional pane, because these things are capable of doing depth. They just don't move in the 3rd dimension while they're machining, typically. We are going to do I'll start easy. I'm going to do a contour on the outside. So I'm going to click 2D contour. The first thing it's going to ask us for is the contour selection. Even though it's in the 2nd tab, it's what's selected by default. We're going to click the bottom edge of the person's face. Then we're also going to select tabs. And we are going to do triangular tabs with a width of 1 inch and a height of 0.1 inches. And we're going to do points. And again, what tabs are is they prevent the material from flying off the machine when it's finished cutting. So you have to cut these after you're done with a chisel or with a saw. And the reason I like to use triangular tabs is because they prevent the machine from plunging. For the tool, if you are not in this class, you won't have this tool library, so you'll have to use the samples. But if you are in this class, everyone watching this video is in the class. I'm not going to be a YouTube star. Huh?
If you get 2 million hits on a YouTube video, you get $50,000.
Wow. Huh. That'd be nice. The tool for this, we're going to use the 1/2 inch compression bit. We might, in real life, be using a 1/2 inch bit that isn't the compression bit, that has different geometry on the flutes. But all that's important, the diameter is correct, and the number of flutes is correct. Everything else is just kind of nice to be correct, but not necessary, because the robot doesn't know what tool it has. So now you can see a ghosted image of our tool. That's pretty cool. Coolant we don't have, but it probably should be disabled. And one nice thing about Fusion is it keeps the feed and speed associated with the tool, so you usually don't have to mess with these, assuming that the tool library you're using is designed for plywood. Because if you were cutting like plyboo, which is like very hard and dense plywood, you'd have to use different settings. If you're cutting MDF, you could get away with faster settings, and if you were cutting metal, everything would be different. A lot of these numbers would be different. But great. Any questions about the tool tab? Awesome. Oh, the 1/2 inch compression bit. So it's in the shopBot. It's in the SFSU tool library. 1/2 inch compression. Oh, one weird bug about Fusion is always select, if it's open and you're in here and where it says documents, always select it there, because every time you select it here, it re-imports a copy of the tool. Which is really weird. But if it's already in use, like if it already has this arrow, click the one with the arrow, or else it will just have duplicates of the tool in your part. and it will confuse the shopBot. It'll ask you to change the tool when no change is necessary. Cool, so now let's just click OK and see what happens. Just so we get a little bit of excitement in our lives. Any issues with this toolpath?
You don't have a nice smooth angle.
Yep, that's one issue.
It's going directly vertical down.
Yep, that's another issue.
You could probably use more tabs for safety.
That's a good intuition, but I cough at the face of safety. No, it's two is usually enough for a part this small. How many blue lines should there be?
3, 2.
Yeah,
3.
3's cool, 2's fine, 1's not okay. Because you're only allowed to go as deep as the tool is wide. So half-inch bit can only go half-inch deep in one pass. So I'm going to go back in here, and I'm going to change all those things. In passes, I'm going to collapse this because my screen is small, and I'm going to do multiple depths. Maximum roughing step down, 0.5. And then I'm going to use even step downs. Then I'm going to push enter. And now you see we have two blue lines, and only one of them has tabs, which makes sense because the tabs don't need to be super thick. And I'm going to go back in there again, and see these green lines? I'm not a fan of these green lines. These are called lead-ins and lead-outs. And what these do, if I click simulate, they start off the part and then go into the part. But I think that it's annoying because it could cut an adjacent part if your lead-in and lead-outs are too big. And also, they don't really solve that many problems. So instead, when we go to passes, linking, I'm going to uncheck lead-in. I'm going to uncheck lead-out. I'm going to disappear this. And I'm going to check ramp. And what ramp does is instead of leading in and lead out, it actually follows above your geometry, like your blue lines, and does a subtle ramp. I'm going to do 10 degrees. Let's see how that looks. So you see now this red line starts well above the material and nice eases in really gently. Eases in gently, and then follows the blue line, comes around, eases down again, whoosh. Finishes the second tab, and then plunges straight out, or it doesn't plunge out. What's the opposite of plunge?
Extringe.
Extringe. It extringes straight out. I think it's retract, if people like real words, but extringe works for me. So cool, this is looking pretty good. Geometry, we have tabs. Heights. The default heights are pretty good, I think. Yeah, we don't have to mess with these. Passes we already did. Multiple depths. Oh, and we're doing conventional for the whole part, right? What did it say yesterday? Yep, conventional. Cool. So this error here just means that something, or maybe it means nothing. Let's see what it means. We're not going to worry about the lifting feed plane to topmost ramp. I think when you use ramping, it just changes the defaults for the planes, but yellow warnings aren't such a big deal, unless they say collision. This is the thing the next thing I'm going to do is I'm going to do what's called boring out this hole. Maybe this hole holds 3/4. That's what it's for. You put 3/4 in that hole so you can have 75 cents ready to go anytime. This is where you keep your beads, and this is where you keep an apple. I'm trying to think of some use for this thing. It's really hard. So to cut a round hole, there are drilling operations, but those are best done with drill bits. And we're not going to use a drill bit for this part because that would be another tool change. And we only have, the holes we have can easily be made with an end mill. But the trick with end mills is you don't want to plunge unless you absolutely have to. So there's this this tool called bore, which can make cylindrical pockets, also known as holes, and other things that are round, including little pegs, like in the drawing. This drawing is a great example of two setups. You see how they're on the screen? There are two little tridents. There's this one and this one. Those are the home points, the origins, for one setup and another setup. So the part is either being flipped by the operator, that's us, or by the robot. Yeah?
Draw the dog bones in the interior corners by the eyes or the cheeks of the monkey face?
Yes, you would if you cared about those corners.
Okay.
You don't need a dog bone every interior corner. You only need to dog bone interior corners that are going to be interfacing with something that's square. Does that make sense? If you had an aesthetic reason that you wanted those corners to be sharp, your best bet would be go in with a file after it's cut and just go until it's sharp. But yeah, that's a great eye. And these are here on purpose in order to show that the router can't cut sharp angles. So what he's saying is that this is not going to be sharp once we cut it on the router. It's going to be really, really round because a 1/2 inch bit looks like this. Cool, so I'm going to do bore, and it's going to automatically select the same tool as last time. Great. And for geometry, cylindrical face selections. So I'm just going to click the bottom. No, the cylindrical face is the bent face. You can't click the bottom, you got to click the side. And cool. Heights, we'll just use the defaults. Just to go over what heights do. Clearance height is where it goes at the beginning and the end of the part, and anytime it's moving a significant distance. I don't know the line for that. A retract height is the place it goes whenever it's moving at all, like without cutting. So it needs to be above the material. Top height is where it's going to begin machining. And bottom height is where it's going to stop machining. Does anybody see an issue with the heights right now?
Yeah.
What is it?
Well, you haven't cut the little square with the dog bones out yet, so it's going to start machining and machining as it cuts.
Yeah, exactly. And if I click OK, oh, it should give us a collision, but it doesn't. That's unfortunate. Maybe yellow isn't what I think it is. Yeah, so there's two ways to fix this. One way is to change the top height, which is currently whole top, which is right here. We could change the top height to be model top or stock top, which in our case are the same. And now it has no problem with that at all. But I'm going to keep it there. I'm going to keep it at whole top. And we're going to solve this problem a different way. So again, all we changed on this was same tool. For geometry, we clicked the internal circular face. And everything else was the default. Oh, I'm sorry, except for direction, which is going to be conventional. So that's in passes. So instead of making this do more work, since we have to mill the pocket anyway, I'm just going to add the pocket. And a pocket is any milling that's done that's like bounded by walls. They're really common. And the difference between pocket and adaptive clearing is just that adaptive clearing is more aggressive and makes decisions that are difficult for humans to understand, like in terms of when it goes where. I'm gonna use, actually, let's just call, who wants to use, what should we use? I actually don't think it matters very much. It might save us 5 seconds.
Pocket.
Cool, Pocket. Again, using the same tool, the same feeds and speeds, so the first tab is the same. For geometry, we're gonna select the Pocket. And you could select the border or the face. Which one should I select in this case? Is it the face? So the face would be great, but I think that if we select the face, no, yep, actually it doesn't matter in this case. I was mistaken, I thought the face would ignore the hole and go around it, but no, they're the same. It mills out the whole thing in both ways, so yeah, correct. So now what this does by default is it plunges into the material, does a square, moves outward, and does another square. Just for fun, I'm going to delete this. Delete. And I'm going to see what 2D adaptive clearing does. Okay, this seems really inefficient. But it's probably better for the tool because it's not cutting as more aggressively. This does, plunges in, does a spiral until it gets to the border. Yeah, I don't like this at all. Nope. So delete adaptive, sorry, back to 2D Pocket. The first thing it asks you for every time you make a new tool path is the geometry, so we're going to click that face. And then moving on, the heights, retract, the default should be fine. The top height is the stock top, and the bottom height is the selected contour, so that's great. There are two problems in the passes tab. Anybody know what they are?
Do you adjust the that one?
Yes, great guess. We're doing all conventional today because I think it's better for plywood. And the other issue, here, I'll run this part. I'll just hit enter. And I'm going to push simulate. Stock to leave. Look at that. Who the hell would want that? It's like, no, I wanted to cut all the way to the edge. I don't want to use a CNC machine to get close. I want it to be right. So it assumes that you're going to go back in and do a finishing pass, which isn't usually necessary for wood, for at least 2D things. So I'm going to uncheck stock to leave, and now it will cut things at the actual right size. Maximum step over, this is really aggressive. I think the rule for the people's usual baseline is to do 2/3 of the tool or less, and 0.475 is like 99% of the tool. You know, what's 0.5 divided by 0.475? I'm sorry, what's 0.475 divided by 0.5? I know how to do math. 95%. Yeah, that's too much. So what we want to do is we want to multiply 0.5 times, by like 50% or 2/3. So I'll just say 66. That makes sense. So yeah, 0.33 inches or something. So because you don't want it to, if you make it 100%, then the bit is going to go from here to here, and that's a lot of work for the bit. If you make it like just a little bit, you're going to be waiting a long time because it's only moving over a little bit at a time. But 2/3 of the bit size is a really good place to aim for. So now I'm going to click OK. And now you see it does more same number of passes. But now it actually goes all the way into these corners, which is what we want. The entry, make the entry more aggressive, save some time. I'm going to get rid of the lead-ins and lead-outs, just like for the other ones, just because they don't really seem necessary. Now let's take a look at that. looks great. And we'll see when I run it. You know, I'm gonna make the lead-in less aggressive because that 10 degrees looks kind of like a lot actually. I'm gonna do 5 degrees. There you go. Now it looks more playful and springy. And you see it starts off the material, which is good because the material might be bigger than we think it is. And yeah. Any questions about Pocket? Great. What's something that I mentioned before that was an issue? That was not a well-phrased question.
Lead-ins. Green lines.
We're doing the bore right now after we do the contour. Does this order make sense? Are any of these things in the right place?
No.
No. What should we do first?
Probably the pocket and the board.
Yep. First the pocket because the bore requires the pocket to be done before the bore can be done safely because the bore starts inside the pocket. And 2D contour should always be done last because you want your part to be as stable as possible while you're working on it. And once you cut it out, it's only being held on by these tiny little tabs. These tiny little tabs. Stock. Tabs look like that. Cool. So that's it for the 2D operations. We have 3 more operations to do for the eyeballs.
Roughing pass.
Yeah, and for that we're going to use adaptive clearing. So under 3D, adaptive clearing, again, same tool, same settings, so convenient. It's asking us for the geometry. And I'm going to click this circle and this circle. And I'm going to click OK and see what happens. Nope. That was wrong. So this is a really... That's super weird. Okay. Get back into that. Edit. It's good to make mistakes. No, not stock contours, machining boundary. Sorry. Selection. So stock contours is something else that I've never used. But I think it just does everything it can within that contour, and it's a really inefficient way to work. Instead, we only want to do the eyeballs because this face of this thing is already flat. So machining boundary is defaulted to none. We're going to do selection, and we're going to click the 2 eyeballs. So it'll ask you for clicking, and you click twice. Tool containment. I think there's a good mouse over for this. We want the tool to go outside the boundary. The other 2, actually, all these are fine in this case because we're not doing a finishing pass. But does that graphic make sense? The difference is whether the tool is allowed to pass that line and by how much. I'm going to turn off rust machining because we're not using it, and that seems like a pretty good reason. There we go. So if we simulate this, you see it does a spiral in, then it goes over and does a spiral in again, then it goes over and does a spiral in. Is it doing anything stupid?
Why does it just stay on one?
Yeah, that's a really good question. That's a great question for bad defaults. So if you go to Edit and then Linking, maybe it's in passes? Should be a thing called, well, we're going to uncheck stock. Oh, stock to leave is actually going to be on this time because we're going to do a finishing pass. Feed optimization? Nope. Smoothing? Nope. Sorry? Where do you see that? Yes, thank you. That's exactly what we're looking for. Now if I push enter, it only makes one pass. Thank you. Good eye. So it goes in with a spiral, and then goes over and does that again. And this is just removing enough material that when we switch to the next tool, that tool won't be overburdened. And usually roughing is done with a square end mill because they can cut faster, and finishing is done with a round end mill. So yeah, now I'm going to show you finishing. I'm going to do a quick review of that because that didn't go well. For tool, it's just the same, the 1/2 inch flat compression bit. The feeds and speeds are all the same, so everything in the tab 1 can stay the same. For geometry, you're going to select selection, and then you're going to click the 2 eyeball socket holes. And then for tool containment, tool outside boundary, no additional offset, uncheck rest machining. Heights can be the default. Passes, you want to check order by area. And you want to, this time and only this time, you want to leave stock to leave checked. And this leaves us some material so that when we mill it later, there's something left to mill. Linking. We can make this 5, be a little bit more aggressive. And then I'm going to hit enter. Cool. Now, we're going to do the 2 eyeball sockets with different strategies. One of them is going to be parallel, and the other one is going to be spiral. And the point of that is just to show how different strategies actually result in different parts, because the finishing, the difference will be visible because of what's called scalloping. Scalloping, not getting scallops from the bottom of the ocean, but CNC. Images. This is an example of where it looks really cool. And this is an example of maybe where it looks less cool. Because the bit is round, it's always going to have these little waves. Oh, there you go. Look at that. Nice diagram. Cool. So 3D, and then spiral, and then click the circle, and then just click OK and see what happens. Nope. That's kind of cool, though. That wouldn't go so well. I'm going to double click this. I'm going to change 2 things. One thing is I've got to change the tool. For this, we're going to be using the 1/2 inch ball. And for geometry, machining boundary is, we got center points are here, but the machining boundary, we actually have to select or it'll keep going. Tool center, on boundary, sure. Now if I click OK, much better. I'm going to do a quick simulation so you can see what it's doing. Woo! And it actually shows you the scalloping. I don't know why the color is so awful. You have choices, but they're not very good. Yeah, so that's one way to do it. And if we made the step over tighter, if we made a closer distance between passes, it would look better. And another thing we could do is we could move the tool center outside boundary. And now we'll do this. And now we'll actually finish the shape, because before it kind of stopped suddenly once it hit that line. But now it has a more subtle stoppage point. So I'm going to go back in there, and I'm going to talk about step over. Step over right now is 1/4 inch, which is great. That's less than 2/3 of the bit diameter. Direction, you know, this could matter a little bit for just surface finish, but I'm not going to worry about it. Both ways we'll do. We'll let it. What doesn't care between climb and conventional. This can be more efficient if you're doing things like zigzag toolpaths and up and down milling. The confusing is it doesn't use the same terms for this one as for the other one. But for this, we'll just leave the defaults. So 1/4 inch step over and everything is the default. Linking. This all looks fine. So it plunges in, which is totally okay because there's no material there. And then it does a spiral. Any questions about that one? Cool. Then we're going to do 3D parallel, or zigzag as I call it, because, I don't know, it's zigzaggy. Machining boundary, silhouette, and then let's see what happens when I click OK. Great. I think that's actually totally perfect, just for the defaults. Yeah, step over is 1/4 inch. Lovely. So now just quickly, I'm going to move the adaptive up one so that the contour is happening as close to the end as possible. Why am I not putting the contour all the way at the end?
Change your bit.
Yeah, we changed our bit. You see how it says T4, T4, T4? These are all with tool 4, and then these are with tool 2. So if I'm going to click the main setup and then click simulate, we can watch the whole thing. It does a spiral in to get to the pocket, then it does the pocket, then it begins doing the bore, gets to the bottom of the bore, comes over here and does the adaptive clearing, comes over there and does the adaptive clearing. Then it goes over here and starts ramping in slowly to do the contour. Then it finishes its first pass. It goes in deeper by ramping. Then it ramps up for the tab, ramps up for the second tab, and now we're finished with tool 2. We switched to tool, we finished with tool 4. We switched to tool 2. Now it's doing the spiral and the parallel, the zigzag. And you can see, I'm going to uncheck tool path because it's not what we're worried about right now. You can see that the surface finish between one eyeball and the other eyeball are super different. And in fact, the pink is from the previous tool path, so we didn't even get rid of all the marks from the previous path. This is because our step over is really wide. And I have the step over wide on purpose because I don't want this to take a long time on the machine. If we look at statistics, 1 minute and 26 seconds. That's too fast. So I'm actually going to go back in right now and I'm going to make the step over for the finishing passes, the spiral and the parallel. From 1/4 inch, I'm going to make it into 50,000ths of an inch. Look at that. 50,000ths of an inch is almost exactly 1 millimeter, I think. That's 1.2 millimeters. Edit, and then passes. Now if I go back into simulate, go all the way to the end, so much smoother. But they still don't look the same. Cool. Great question. Thanks for reminding me. 2 minutes and 3 seconds. It's because the eyes are small. Is that a question? Or a stretch? Cool. I hope somebody else on YouTube finds this and they're just like, oh, I remember school. Stretching. Getting called on. Classic. The last thing we're going to do is we are going to post-process. And that lives under Actions, and it's the icon that says G1, G2. And what this does is it converts, I'm not going to read it out loud, it takes what we just programmed and makes it into G code. And what G code is, I will show you. On Windows, this window is a lot scarier. Like it has like way more options, but it's exactly the same. You just want to pick the post processor for the shopBot, which is already in Fusion. These are all of the CNC machines you can run out of Fusion without doing anything. So like without even installing anything. Just to give you an idea of after this how many machines you're going to be qualified for. There are two shopBot options. There's the OpenSBP and the ISO. Our shopBot, as far as I can tell, only works with OpenSBP. So don't use the ISO. It's for metric shopbots. Communist shopbots. Program number really means program name, but you can get another chance in a second to rename it. So I could call this, what's it called, Paul Ringo? Ringo Paul. Ringo _ Paul. Program comment. I've never really used this, but like we can say, hey, can you read this? I don't know if it goes anywhere. Let's find out. I think document unit is inches, but just to be explicit, I'm just going to put inches. I'm not going to look at any of this stuff because it's extra. Windows, it's a lot scarier than this, but it's similar thing. Downloads. No, Dropbox, current projects, DES. Fall or spring? Fall? Thanks. shopBot. G code. See, you can rename it here also. So what you put earlier doesn't make that big of a difference. And then you're going to click Save, and it's actually going to open it for you in a text editing program. Such as TextEdit. And you can see how this works. Hey, so here's the name of our program, and here's the comment. So the comment made it in. It just tells the machine where to go. This is the X coordinate, this is the Y coordinate, and this is the Z coordinate. And the M3 is the different types of movement. Like if we keep scrolling, we might find some M... Is it all M3s? This doesn't matter so much, except for one thing, which is I'm going to actually ask you... I think CG is probably fast moves, and M3 is probably slow moves, but it doesn't matter. The only reason you ever need to look at this is to search through it to just like do a quick scroll through and potentially check to see if any of your negative numbers are large, because that means it's going to go into the machine. I made a mistake on this toolpath, so we're going to have to change it. We want to go into the bed a little bit. So I'm going to go back into 2D contours. And the default height for bottom is 0. And I'm going to make that negative 0.015. So that's 15 thousandths of an inch. 0.38 millimeters. So just enough so that I'm sure that we're actually cutting through. Because sometimes the plywood will actually bend under the bit, and you'll have a paper thin layer at the end, and that's no good. So we want to actually cut past the bottom. And now you see that if we zoom in really close, it cuts past the bottom. And now I'm going to post-process that again, the whole thing again, by clicking Setup and then Post-Process. Demo, Ringo, Paul, R2. And now if I scroll, there's a lot of negative ones here. The previous machine I did this with wasn't a shopBot. But the point is that if negative 0.01, There you go. You can see it's going negative at some point in the code. Oh no. But it's only going a little bit. Anyway, that's not so important. But sometimes if you don't intend to go into the bed, it's kind of nice to search your code for the negative symbol, just to make sure that you're not going to go into the machine. But we're not going to actually require that because it seems the shopBot uses -1 to mean something other than -1. Because this is too many numbers to mean that. So I'll cut this part out of the video. And let's take a break. Let's meet back at the shopBot in 15 minutes.